Hello everyone, we are going to start a new unit today. Our unit is on trigonometry, and our first set of notes is going to be about arc lengths, sector area, and also radian measure. So first, an arc length, if we define it, it's going to be the distance between 2 points on the circumference of a circle. And when I say distance here, I think I am going to specify that it is a curved distance. It's not a straight distance. It goes along the circumference of the circle. It just follows it. Okay, so in my picture here, if I draw a center point, label it with a C for center. I draw a point here and a point here. We'll label them A and B. If I create a central angle, then this part of my circumference here, the intercepted arc that we talked about in our last unit, this is going to be what your arc length is. Now in the last unit, we found that arc measure, like the degree amount. Now we're actually going to find the length of it, like in units, centimeters, feet, etc., etc. Okay, and to do that, your formula, I'm going to try and put it beside my definition here. Okay, the length of arc AB is going to be the measure of arc AB, so the degree amount, divided by 360 and multiplied by 2 pi r. Okay, so that's your formula. And the reason why you're multiplying by 2 pi r, that's your circumference formula. So you're pretty much figuring out how much of the circumference your arc is taking up. Okay, for a sector, the definition is the region bounded by 2 radii and their intercepted arc. So in my picture, I like to think of a sector kind of like a slice of pie or pizza, however you want to think about it. So like I said, in the picture, this would be our sector. It's this area inside of my angle and between the angle and the arc. Your formula to find the area of a sector is going to be the measure of arc AB, so the degree from A to B, out of 360 multiplied with pi r squared. Okay, and hopefully it makes sense why you are multiplying by pi r squared, because that is your area of a circle formula. And so since we're finding the area of this slice of pi, or the slice of the circle, you have to use your area formula to get it. Okie dokie. So in our first set of examples, we are told to find the arc length of the following and round your answers to the nearest tenth. So for part A, we are told that we have a 315 degree central angle. And we talked in our last unit that central angles are equal to their intercepted arcs. So if I have a 315-degree angle, then I also have a 315-degree arc going from here all the way around to here. So my formula to find an arc length, so length, and I'll say from A to B, and I'll even label them on the picture, A and B. My A is kind of hard to read, so hold on one second. Let me rewrite that. So from A to B. All right, so length of arc AB is going to be the measure of arc AB, which is 315, out of 360 degrees, multiplied with 2 pi times r, and our radius in the picture is 11. Okay, so if I reduce 315 over 360, it reduces to 7 over 8, multiplied with, and I can do 2 times 11, which is 22 pi. So now all I have to do is multiply my 7 over 8 multiplied with 22 pi in my calculator. So let me pull that up. Okay, so we're doing 7 over 8 multiplied with 22 pi. So we get 60.5-ish. Okay, so our length of arc AB is approximately 60.5, and we do need to put units because we are talking length here. I just changed my equal sign to an approximately. The units in the picture are feet. Okay, so the arc length is approximately 60.5 feet. It was 315 degrees, but now we have found the length of it. All right, for part B here, okay, if we have a central angle that's 150 degrees, we know that the intercepted arc is also 150 degrees. We can say that we've got point A and B here, okay, and so we're going to figure out the length of arc AB. Okay, we know we've got 150 over 360 multiplied with 2 times pi times our radius, which is 19. Okay, so we've got 150 over 360, which can reduce to 5 over 12, multiplied with, and 2 times 19 is 38 pi. So we'll just type that in our calculator really fast. Okay, we've got 5 over 12 multiplied with 38 pi, which is 49.7-ish. So we can say length of arc AB is approximately 49.7, and the units in this picture are feet. So it was a 150-degree arc, but the length of it is 49.7 feet. Okie dokie. So now in example 2, we're going to find the area of the shaded sector. Okay, and like I said, a sector is kind of like a slice of pie, so the yellow part is what we're finding the area of. Notice it does say leave your answers in terms of pi. Okay, so we've got a 45-degree arc in our first picture here. And I will say that this is A and B, and then in our second picture here, A and B. Okay. We know that our area formula, here I'll scroll up, is the measure of our arc over 360 multiplied with pi r squared. Now, you know what, hold on, I'm going to try and move my writing over a little bit. There we go. Okay. So our first example here, we want to find the sector area, and it's going to be our arc measure, so 45 over 360 multiplied with pi times our radius squared, so 18 squared. We can reduce 45 over 360, and that reduces to 1/8. And then 18 squared is 324, so times 324 pi. Since this says leave your answers in terms of pi, all we have to do is 1/8 times 324. And so we've got 1/8 times 324, which is 40.5. Okay, so I can write my answer, sector area equals 40.5 pi, and my units are yards, so yards squared. The reason why it's squared, this is area is squared. So there's our area for the first circle. For our second circle, notice that 120 degrees is not in the sector that I'm trying to find the area of. So since this is a diameter, I can do 180 minus 120, and I know that that angle at the center here is going to be 60 degrees. So let me get rid of this blue line here, don't need it. We've got 60 degrees here, which means my arc is also 60 degrees because it's a central angle and they equal their intercepted arcs. Also, since that 26 is the diameter, I need to figure out my radius, which is half of that, so 13 meters for the radius. Okay, so we've got sector area equals my degree for the arc, AB, is 60 degrees out of 360, multiplied with pi times my radius, which is 13, squared. Okay, so 60 over 360 reduces to 1/6. And then 13 squared is 169. So times 169 pi. And all we have to do is 1/6 times 169. Okay, now that's not a pretty decimal. It's not 0.5, 0.25. It's weird. So I'm going to hit math, enter, enter, change it to a fraction, and I'm going to use that. So 169 over 6, easy enough. Okay, so our sector area is 169 over 6 pi, and then our units for this picture would be meters squared. Yet again, squared because it's area. All right, so we need to talk about a new way to measure angles. And what we've been used to is degrees. You know, 30 degrees, 45 degrees, that's how we measure angles. Well, now we're going to talk about how to measure angles in radians. So a radian is an angle measure that relates the circumference of a circle to its radius. So, I'm going to start out by drawing the center of my circle here. And I know that half of a circle is 180 degrees, and a whole circle is 360 degrees. So I'm going to start out doing is drawing a radius. Okay, so here's my radius R. And I can really draw a radius anywhere on this circle, and it's going to be the same length. Okay, so let me see if I can use my smart board to kind of show you what a radian actually is. All right, so if I take this radius length, okay, and I'm going to move it out here, kind of rotate it a little bit, and I'm going to try and put this radius length around the edge of my circle. Okay, so hopefully you know what I'm talking about here. I'm taking this radius length and I'm curving it so that it fits along the circumference of the circle. So let me just get rid of this little tail here. Okay, so that would be 1 radian, okay? 1 radian, because I took the radius and I put it on the circumference of the circle. It measures 1 radian. Okay, now I'm going to do this again, taking my radius length, and I'm putting it up here on my circumference. Okay, so got another one. This would be another radian. Okay, and then I'm going to do this again here. Rotate it, put it here. Okay, let me get rid of this little tail here. Let me just go a little farther. There we go. Okay, that's 1 more radian. Now the thing is, 3 radians does not go around half of the circle. You actually need a teeny tiny bit more, and that teeny tiny bit more is 0.14 of a radian. Okay, so how many degrees did I say was half of a circle? Said 180 degrees is what half the circle is, right? Well, I just figured out that half of my circle is also 3.14 radians. Or, if you guys have caught on, 3.14 is what pi is approximately. So 180 degrees is equal to pi radians. Okay, so like I said, radians are just another way to measure an angle, or in this case, measure the distance around a circle. As opposed to degrees, you now have radians. Okay, now we're going to talk about how to convert back and forth between radians and degrees. So when you are converting from radians to degrees, you're going to multiply by 180 over pi. Now I want you to think about it. On this last slide, I said that 180 degrees is the same thing as pi radians. So if 180 and pi are equivalent, we're technically multiplying by 1 because 180 and pi are equivalent. So we're not changing the measure, we're just changing to a different form. Okay, and then when you are converting from degrees to radians, you multiply by pi over 180. So the same thing, just flipped. Okay, the first option when you're going from radians to degrees, Pi is on the bottom because you're actually trying to get rid of pi, so you need to be dividing by pi. In the second option, when you're going from degrees to radians, notice pi is on the top, and that's because you're actually trying to put pi into your answer. So you're multiplying by pi on the top instead of trying to divide it out. Okay, so first set of examples, we've got degrees and we're changing to radians. So you do the degree amount multiplied by pi over 180. Because remember, if I'm going from degrees to radians, I'm trying to put pi into my answer, so it's on the top. We've got 30 pi over 180, and we're going to reduce 30 over 180, and that reduces to 1 over 6. So I can just say this is pi over 6, because I don't have to say 1 pi over 6. And since I've been writing everything in red and blue so far, let me change all of these. Let's change them to red. Let's not throw off my pattern here. Okay, for number 2, we've got 45 degrees multiplied by pi over 180. Yet again, we're trying to put pi into our answer, so it's on the top. We've got 45 pi over 180, and we will reduce 45 over 180. And that reduces to 1/4, so 1 pi, or just pi, over 4. We've got 60 times pi over 180. So we're going to reduce 60 over 180. And that reduces to 1/3, so 1 pi, or just pi, over 3. 90 pi over 180. 90 over 180 reduces to 1/2, so that would just be pi over 2. And for number 5, we've got 315 pi over 180. Okay, 315 over 180. Let's see what that reduces to. 315 over 180. Got 7 over 4. Okay, so this is 7 pi over 4. Okay, we've got negative 120 degrees, which, y'all, we're going to talk about negative degrees a little bit more in the days to come. Negative degrees just are angles that open up in a different direction than what we're used to. But you can still change them to radians. So we've got negative 120 pi over 180. And 120 over 180 reduces to 2/3. So we've got negative 2 pi over 3. And then we've got negative 275 pi over 180. Let me see what negative 275 over 180, math, enter, reduces to. Okay, negative 55 over 36. So negative 55 pi over 36. And then negative 42 pi over 180. And negative 42 over 180, math, enter, reduces to negative 7 over 30. We've got negative 7 pi over 30. So that was converting from degrees to radians. Now we're going to do this the opposite way. We're going to take radians and change them into degrees. Now remember, when we're doing that, we need to try and get rid of pi, so we're going to be dividing by pi. Okay, Okay, we've got 3 pi over 4, and we're multiplying by 180 over pi. Like I said, we're trying to get rid of pi, so we're dividing by pi. And the fabulous thing is here, the pi's can cancel, and so you've got 3 times 180 divided by 4. Okay, so 3 times 180, let's do this, 3 times 180, which is 540 divided by 4, 135. So 540, 135, 540, 135 degrees. Okay, we've got 5 pi over 4 multiplied by 180 over pi. Pi's cancel. So we're doing 5 times 180 divided by 4. 5 times 180 divided by 4. Okay, so 900 divided by 4 is 225. 900 divided by 4. 225 degrees. 3 pi over 2 multiplied with 180 over pi. So the pi's cancel. And we've got 3 times 180, which we know is 540. But this time we're dividing it by 2. So 540 divided by 2, 270. 270 degrees. Okay, now, these two are a little bit different. Notice they don't have pi in them. And it's just saying 1 radian and 2 radians. Now, remember, I told you a radian is just a certain amount around the circumference of the circle. Okay, so we're saying 1 radian versus 2 radians, like my red piece, and then 2 radians would be my red piece plus my green piece. Okay, so back here, we're still going to follow the same method. Okay, so we've got 1 radian multiplied with 180 over pi. The only difference here is there's no pi to cancel out. So I essentially just have 1 over 1 multiplied with 180 over pi. Here, I'm actually going to put that in blue. Okay, so I'm adding this over 1. Okay, so that means we have 180 divided by pi. And if I type that in my calculator, 180 divided by pi, I get 57.3-ish. Okay, so 57.3-ish degrees. Okay, and I'm going to make this a little squiggly equal. It's approximately that amount. Okay, and same thing for number 5. We're doing 2 times 180 over pi. So if I stick that 2 over a 1, okay, 2 times 180 is 360 divided by pi. And so that's what we're putting in our calculator, 360 divided by pi, which is approximately 114.6. Approximately 114.6 degrees. 114.6, yeah. Okay, and that was changing from radians into degrees. Okie dokie, so at the beginning of our notes, we talked about finding arc length and sector area when our angle measures and our arc measures were in degrees. Now that we've talked about radians, we need to adjust our formulas and have a radian version of our formulas. Okay, so your arc length formula from earlier was the measure of arc AB over 360 multiplied with 2 pi r. Okay, now remember, I said 180 degrees is equal to pi. Okay, we figured that out a few slides ago. Which doesn't that mean that 360 degrees would be 2 pi? Because 180 times 2 is 360, pi times 2 is 2 pi. Okay, so if I replace 360 degrees in this formula with 2 pi, okay, I've got measure of arc AB now over 2 pi multiplied with 2 pi r. Well, we've got a 2 pi that we're dividing and a 2 pi that we're multiplying, so they can cancel. So right now my formula says the measure of arc AB multiplied with r. Back in Math 2, you talked about angle measures and how they could be called theta if you were missing that angle measure. Theta is a Greek letter, and in this case, it gets used when your angle is in radians. So I'm going to say angle measure in radians. Okay? So our measure of arc AB, we're going to switch that out with theta because theta represents our angle measure, or in this case, the arc measure. Because remember, central angles and their intercepted arcs are equivalent. So we've got theta times r. Okay, so our new arc length is going to be S equals r theta. Okay, S stands for arc length. R stands for radius. And theta is our angle in radians. Okay, our sector area formula was the measure of arc AB over 360 multiplied with pi r squared. So yet again, I'm going to replace that 360 degrees with 2 pi. So I've got the measure of arc AB over 2 pi multiplied with pi r squared. Well, this pi and this pi can cancel. So instead of having the measure of my arc being divided by 2, I'm going to say that this is half of the measure of my arc multiplied with r squared. And one more time, I'm going to replace my arc AB with theta, which stands for your angle measure in radians, which is going to be equivalent to the arc because central angles are equal to their intercepted arcs. So we've got 1/2 multiplied with theta multiplied with r squared. Okay, so our new sector area formula is 1/2 r squared theta. Okay, the r is still your radius, and theta is still your angle in radians. Okay, now, I know that my arc length is r times theta. So if I rewrite this formula, I've got 1/2 times r times theta. Isn't that technically what this says? Yeah. Okay. Here, I'm actually going to do my arrow from this one. Okay. My r theta is going to get replaced with my arc length formula over here. It says r theta is equal to s. So if I replace r theta with s, I have a new version of my sector area formula, which is going to be 1/2 times your radius times your arc length. Okay, radius, arc length. Here, I can't fit arc length, hold on. Okay. Y'all, these are really not all that complicated. I was just showing you where these new versions of the formulas come from. Okay, if it was a little confusing, it's okay. You just need to know how to plug into the formulas, not how to derive the formulas. Okay? All right, so in our first example, we are told we have an angle with a measure of 4 radians, and it intercepts an arc with a length of 18 feet. What is the length of the radius? Okay, if I drew a little picture here. Okay, I've got an angle, and I'm going to make my pen skinnier. Okay, so our angle has a measure of 4 radians. So I'm going to put a 4 here. The arc has a length of 18 feet. So from here to here is 18 feet. What is the length of the radius? So here's my r that I'm trying to figure out. Okay, now I need to figure out which formula I'm supposed to use. So I'm going to label this information in the problem. We've got 4 radians, and that's our angle measure. Since it's in radians, this is theta. The arc length is 18 feet. Arc length for us is s. And they're asking you the length of the radius, which is r. Okay, those 3 variables, theta, s, and r, if I look back at my formulas, that's my new arc length formula. S, r, and theta are all in that one. Okay, so I'm going to write that down. New, you know what? No, I'm not. I'm just going to write the formula. S equals r theta. This is our new arc length formula when we're in radians. So let's plug in what we have. We've got 18 for our arc length. We're trying to figure out r for our radius, and our angle measure is 4 radians. So to get my r by itself, let me move this over here, we need to divide by 4. Okay, so 18 divided by 4 is 4.5. So we've got our radius, which is 4.5, and the units in this problem is feet. So a radius of 4.5 feet. Okay, number 2. I'm going to draw a little picture again. And we'll just say that these pictures are not necessarily to scale. I'm just kind of drawing the same picture each time, but with different labels. Okay, so it says the length of an arc is 18 centimeters. Okay, so here to here, 18 centimeters. The radius is 6. And what is the radian measure of the central angle? So we're trying to figure out the radian measure of the angle, that is theta. Okay, so if I label what I have in this picture. The length of an arc, that's S. The radius, that's R. And they're asking for the radian measure of the angle. That's theta. So same formula. S equals R theta. And we're just plugging in. 18 equals 6 times theta. We'll divide by 6. And 18 divided by 6 is 3. So theta is going to be 3 radians. Because remember, theta is your angle in radians. So that's our units here. 3 radians. Okay, number 3. We've still got a circle here. This time we're finding sector area. Okay, so we're finding actually the measure of this slice of pie, the area of it. Okay, we're told we have an arc length, so from here to here is 40 centimeters, and a radius of 12 centimeters. Okay, and we're finding sector area, which means we're finding this shaded bit right here. Okay, since it mentions sector area, and I have an arc length, which is S, and a radius, which is R. Let's look back at our formulas for sector area and see which one has an S and an R in it. Okay, sector area, down here on the right, I have a formula, 1/2 RS. It has S and R in it. Okay, so sector, oops, wrong color. Need to be writing in red here. Sector area equals 1/2. And if I look back at my formula, I have it in RS. Okay, RS. So we shall plug in. We've got 1/2 times 12 times 40. So half of 12 is 6, and 6 times 40 is 240. Okay, so our sector area equals 240. Our units are centimeters, so centimeters squared is the area of that shaded sector that I have in the picture. Okay, number 4, find the area of a sector. Let me draw my picture here. Radius of 7 and central angle of 11 pi over 9. Let me get my skinnier pen here. Okay, so our angle here is 11 pi over 9. And that, since it's in radians, is our theta. What color am I supposed to be writing in? Blue. Okay. So this is theta, angle measure in radians, and then this is our radius, R. Since we're trying to find sector area, okay, so that's the area of this shaded piece here. Let me see if I can do this. Let's see what this looks like. Oh, that is, okay, nope. Let's try this again. There we go. Hey, look, it's shaded. Fabulous. Make sure I'm still not, okay, there we go. All right, so our formula for the area of a sector that has R and theta in it. Area of a sector, R and theta. New sector area, 1/2 R squared theta. That's what we're going to be using. Okay, so sector area equals 1/2 R squared theta. And if we plug in, we've got 1/2 7 squared times 11. Whoops, that's not 11. 11 pi over 9. All right, so I'm going to put my answer in terms of pi first. So I'm going to multiply the 1/2, the 7 squared, and the 11 over 9 and figure out what that is. So we've got 1/2 times 7 squared, that's not a squared. There we go, squared, times 11 over 9. Okay, let me change that to a fraction. Got 539 over 18. Okay, so this is 539 over 18 pi. And so now I will get the decimal approximation for the area of this sector. And I'll do that in my calculator, multiply with pi. So approximately 94.1. Okay, so our sector area is approximately, what did I say, 94.1? Yep. 94.1. Our units in this problem, you don't have units. Okay, so units squared, since it's area. Okay, an angle with a measure of 4 pi over 3 intercepts an arc with a length of 14.7 inches. What's the length of the radius? So here's my picture, here's my angle. Okay, so my angle measure is the 4 pi over 3, and it intercepts an arc of length 14.7 inches. And what is the radius length? Okay, so in my picture, I am finding this sector area. So let's label our different pieces of information. The 4 pi over 3 is theta. That's my angle measure in radians. Okay, an arc length is S. So S is 14.7 and radius R. Okay, so we are talking about arc length and radius and an angle measure of theta. So we're looking for our formula that has S, R, and theta in it, which is our arc length formula here in red. S equals R theta. Okay, so we've got S equals R theta. We're going to plug in. Got 14.7 equals our radius, which we don't know, multiplied with theta, which is 4 pi over 3. Okay, I'm going to divide by 4 pi over 3. Okay, now I'm going to put my answer in terms of pi first, which means I'm just going to do the 14.7 divided by 4/3. Okay, so we've got 14.7 divided by 4/3. Okay, and that's 11.025. So we've got 11.025 over pi still, because remember I was still dividing by pi. I just didn't type divided by pi in the calculator yet. And that's what my radius is going to be. So let's hit divided by pi, and we get 3.5-ish. Okay, so our radius, hold on, let me put this back. There we go. Okay, radius approximately, what did I say, 3.5? Yeah. 3.5, and our units are inches. Last one. Okay, we've got a sector has an area of 32 feet squared with a central angle of 5 pi over 9. What is the radius length? Okay, we've got our circle, and that's, wow, a wonky circle. Try that again. Okay, so our sector area, they actually give that to us this time. Okay, so let me, my shaded region here. Okay, so the blue shaded region is 32 feet. Now, let me make that one a little bit more, oh goodness. Oh, there we go. Okay, so that area is 32 feet. The central angle is 5 pi over 9. So this angle right here, 5 pi over 9. And we're asked, what is the radius length? Okay, so you have your, wrong color. Your angle in radians, that's theta. They're asking you for your radius length. And they give you the area. So we need our area formula that has theta and r in it, which if you look at number 4, that was our area formula that has theta and r in it. Okay, so sector area equals 1/2 r squared theta. And we'll plug in our sector area here is 32. Equals 1/2. We don't know our radius, but our theta is 5 pi over 9. Okay, first thing I'm going to start by doing is multiplying by 2 to get rid of my 1/2 here. Okay, so 32 times 2 is 64 equals r squared multiplied with 5 pi over 9. Okay, and then I'm going to divide by 5 pi over 9. Now I'm actually just going to divide by the 5/9, just like I did in the last problem. Okay, so in my calculator, move it over so I can see what I'm doing. Okay, I'm doing 64 divided by 5/9. Okay, so I have 115.2 over pi, because the pi is still being divided, is equal to r squared. And then I'm going to square root both sides. Now, we're not going to worry about plus or minus because we're talking about length, and length is always positive. Okay, so if I do the square root in my calculator, square root of 115.2 divided by pi, we get approximately 6.1. So our radius is approximately 6.1, and let's see what our units were. Do we have units? Yep, feet.